A warm welcome to one and all. I am Yogeshwari, Assistant Professor, Department of Mathematics, Dr. SNS Rajalakshmi College of Arts and Science, Autonomous Coimbatore. Now I am taking the topic is computational mathematics and statistical computations. This is an BCom course. So topic now I handle the topic is regression equations. What is meant by regression? First of all, the meaning is a study of measuring the relationship between associated variables wherein one variable is dependent on another independent variable, called as regression. It is developed by Sir Francis Galton in 1877 to measure the relationship of height between parents and their children. Regression analysis is a statistical tool to study a nature and extent of functional relationship between two or more variables and to estimate the unknown values of the dependent variable from the known values of independent variable. Uses of regression analysis: it provides estimates of values of the dependent variables from values of independent variables. It is used to obtain a measure of the error involved in using the regression line as a basis for estimation. With the help of regression analysis, we can obtain a measure of degree of association or correlation that exists between the two variables. It is highly valuable tool in economics and business research, since most of the problems of the economic analysis are based on cause and effect relationship. Next, regression lines and regression equation. Regression line of y on x is, this line gives the probable value of y for any given value of x, that means independent variable. So regression line of x y, regression line of y on x minus y equal to byx, x minus x dot. That means x bar, x dot, x dash, these are same on that particular value. So y is equal to a plus bx square. Next, regression lines of x on y. This line gives the probable value of x for any given value of y. Regression lines of x on y, x minus x bar equal to bxy into y minus y bar, or x equal to a plus by. Then regression coefficient. The quality b in the regression equation is called as the regression coefficient or slope coefficient. Since there are two regression equations, therefore we have two regression coefficients. So regression coefficient x on y symbolically written as bxy, and regression coefficient y on x symbolically written as byx. So different formulas are used to compute regression coefficients. First method, regression coefficient x on y and regression coefficient y on x. These are the formulas for regression coefficients. So using the correlation coefficient r and standard deviation sigma, bxy is equal to r into sigma x by sigma y, and then byx equal to r into b is sigma y divided by sigma x. Direct method using sum of x and y. bxy is equal to n into summation xy minus summation x summation y divided by n into summation y square minus summation y of whole square. So byx equal to n into summation xy minus summation x into summation y divided by n into summation x square minus summation y the whole square. When derivations are taken from arithmetic mean, bxy equal to summation xy divided by summation y square, where x equal to x minus x bar and y equal to y minus y bar. And then byx equal to summation xy divided by summation x square, where x is equal to x minus x bar and y equal to y minus y bar. So next, find the two regression equations of x on y and y on x from the following data. So first of all, we have the data in x and y. So x square, just square the values of x is x square, and square the values of y is y square, and both are multiplying in x and y. These values are given below. So we want to add the separate columns. So summation x, summation y, summation x square, summation y square, and summation xy. So here n is equal to number of elements in either series x or series y equal to 8. Okay. Now we will proceed to compute regression equations using normal equations. Regression equations of x on y equal x is equal to a plus by. The two normal equations are summation x equal to n into a plus b into summation y. A summation xy equal to a into summation y plus b into summation y square. Substituting the values in above normal equations, we get 120 equal to 8a plus 160b. 2542 is equal to 160a plus 3372b. So let us solve these equations 1 and 2 by the simultaneous equation method, multiplying equation by 20. So we have these values. Now rewriting the equation, and therefore we have minus 142 equal to minus 172b. This can be written as b equal to 142 by 172. So that is equal to 0.82 82 into 56. Substituting these values of linear equation 1, and we get a equal to a equal to minus 1.5. Thus we got the value of 1.5 and b 0.8256. Hence the required regression equation of x on y is equal to a plus by, x equal to minus 1.5 plus 0.82 5v2. Regression equation of y and x. Next problem, regression equation of y and x. The two normal equations are these things. Substituting the values in the above normal equation, we get 160 equal to 140, 250, 2540 equal to 240. 4 equal to 240. Now rewriting these equations, 240 equal to 1000, 242 equal to 120 a plus so